Assalamu alaikum warahmatullahi wabarakatuh. Hello civil engineers and welcome back to Civil 53 Next, where we simplify structural design step by step. In our last episode, we introduced the statical system and discussed concrete as a construction material. In today's episode, in episode 2, we are going to talk about the second key material in RCC, reinforced cement concrete, which is steel. Why steel? What makes it so essential in a concrete structure? And what types of bars do we use in real construction projects? Without further ado, let's get started. Why do we use steel in concrete? As we said before, concrete's weakness. Concrete excels in compressions but fails under tension forces. That's why we need steel. What is steel's strength? Steel provides excellent tensile strength and ductility, which means perfect partnership between the steel and concrete. Similar thermal expansion rates make these materials compatible. What's about their strong point? Mechanical and chemical bonding creates a unified structural system, which makes RCC effective. So in short, steel bars are ductile, which help them bear tensile forces during seismic activity or sudden changes in temperature. Now let's understand yield strength. What does it mean by yield strength? Yield strength is the stress value that the steel can take while still showing elastic behavior, and stress applied to steel above this value will take it into the plastic zone. So in short, we can say yield strength is the stress at which steel begins to deform plastically. So what is elastic behavior? Before yield point, steel returns to its original shape when unloaded. Plastic deformation, beyond yield point, permanent deformation occurs. The great significance: Fe 500 means 500 megapascal yield strength, approximately 72,500 psi. The value of yield strength depends on grade of steel. Mild steel, Fe 250, has yield strength of approximately 250 MPa. So Fe 250 will have approximately yield strength of 250 MPa. Now let's talk about ductile brittle materials. So what does it mean by ductile materials? Ductile materials can be deformed without breaking. This means that they can be stretched or bent without fracturing. In short, steel can stretch significantly before failing. And what does it mean by brittle materials? Brittle materials, on the other hand, when they are subjected to stress, it will break suddenly and without warning, often resulting in sharp edges and dangerous shafts. In short, like glass and plain concrete break suddenly without warning. So, ductile materials or ductile structures allow evacuation time during emergencies. Safety implementation: ductile provides warning signs before structural failure. Now let's talk about components of reinforcement. We have main bars, stirrups, hooks, cover. Why do we need main bars? Main bars handle tension forces in the structural element, whereas stirrups hold main bars together and resist shear forces. So if someone asks you why do we provide stirrups, you can reply them by saying stirrups are placed at a proper interval to beams to prevent them from deformation, shear failure of beams. This is done to prevent shear failure, which is usually diagonal in case of cracks. We can also say to reduce shear force. Hooks provide anchorage at far ends for better grip. Or in short, we can say why do we provide hooks? To resist seismic movements. And finally, cover. Cover protects steel from corrosion and fire damage. So if someone asks you why do we provide cover, you can reply by concrete covering is provided to prevent corrosion of reinforcement parts in RCC. Reinforcement is prone to fire and corrosion due to atmospheric conditions. Hence, a proper covering is necessary in order to overcome such problems. We can also say to prevent from weather conditions effects. Typical covers for slab use: 25 mm, 40 mm for beams, 50 mm plus for footings. There are many types of steel reinforcement, like hot rolled deformed bars, cold rolled bars, mild steel, Fe 250. Hot rolled deformed bars, most common in construction, ribbed surface for better concrete bonding and greater ductility. Cold rolled bars, higher strength but more brittle, less frequently used in modern construction, limited ductility. And mild steel, Fe 250, plain surface bars, lower strength but higher ductility, limited modern applications. There are other types, which twisted steel bars, weld steel bars. Twisted and welded. Now let's talk about steel grades and their applications. You have grade, yield strength, common application. So for Fe 250, as we said, it's gonna be 250 megapascal. It's used for stirrups, ties, and it's rare nowadays. Fe 415 has 415 MPa yield strength, and it's used in residential buildings in India. Fe 500, 500 megapascal, most common grade worldwide. And we also have Fe 550, Fe 600, which have the yield strength 550, 600 MVA, high-rise building, and industrial structure. In this slide, we can see the regional usage patterns. In Gulf countries, they widely use Fe 500, Fe 550, dominated in UAE, Qatar, and Saudi Arabia. Second, in India. India, they use Fe 415 and Fe 500 are standard choices for the most structures. And the bar sizes ranges from 6 mm to 32 mm based on the structural requirement. So common applications like 8 mm stirrups, 12 to 16 mm beams, 20 to 25 mm for columns. Diameter affects spacing, cover needs, and anchorage requirements. So here is the key takeaways. Material partnership, steel and concrete complement each other perfectly. Strength matters, yield strength determines steel's performance. Integrated system, multiple reinforcement components work together. So global standards, steel grades vary by region and its applications. So inshallah, in the next episode, we will talk about or we will understand structural loads. So join us for our next episode where we will explore how different loads affect structural design decisions and safety considerations. Thanks for watching episode 2 of our concrete basics series, Statical System, where we explore the steel and how it works with concrete in structural design. If you find this video useful, don't forget to like, subscribe, and drop your question in the comments below. And if you missed episode 1, I highly recommend checking it out. In that video, we introduced the statical system and explained why concrete is a core material in structural engineering, its components, grades, tests, and more. You will find the link right here on screen. Click and start building your foundation the right way. So follow me on Instagram, LinkedIn, and do not forget to subscribe here on my YouTube channel. See you in the next episode, inshallah.